Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. We finally got through all the interfaces and all the very short files that we need to create. And now we're going to create the PhysicalEntity class. So let's right click a game object here and let's go to add class. That's going to be PhysicalEntity. PhysicalEntity. And now that's going to also be an abstract class, public abstract class, PhysicalEntity. It's going to derive from game entity and iPhysical for the interface. And if you're using ReSharper, you can just click that red light bulb and implement missing members. If you're not, you'll have to manually add the color, float, rotation, float, scale, vector 2, scale vector, and vector 2 position. You'll have to implement those properties. Okay. So the PhysicalEntity is going to hold it's part of the interface, but it's going to hold everything our entity physically needs, like the position, which we already have here, the texture, which will give us the physical representation of what our object looks like, the origin, where we want the center point to be in our object, the rectangle, the bounds of our object, and we'll have it'll be event driven. We're going to have content loaded events. So there's a few things that this class will end up doing. Let's create a private read-only string here for underscore texture name. So we're going to store this because we're going to pass that into the constructor, but we are going to load that texture when we call load content. So this is going to be a protected constructor. So protected PhysicalEntity, we're going to provide the color, vector 2 position, the string texture name, the float rotation, and the float scale. Now I set this up to only allow a single scale value, and that will set up the scale vector. Remember, we discussed that when we discussed iPhysical. The scale vector will be set to the same value we had in both X and Y. If you want to extend this to have multiple scale X and scale Y, you can. I probably will for the beta release of this, but for now I'm just going to keep it a single scale value. So color is equal to color, and then rotation is equal to rotation, scale is equal to scale, scale vector is equal to new vector 2, and that's just scale and scale, position is equal to position, and underscore texture name is equal to texture name. So the texture name is going to be used when we load our content. Alright, after all these properties, let's create a public event. Event handler, and this is going to be called whenever content is loaded. So if there's something that you want to do once your game object's content is loaded, just sign up to receive events from this event handler, and that will be taken care of. Okay, so the load content here, that's going to be internal virtual void. Load content will only be used internally, so we'd make that an internal accessor. Again, anything you see here, if your needs differ, you can make that public virtual void if you need it. Content manager content. And content manager is from Microsoft.xna.framework.content. So make sure you have that using statement. So we're going to check to see if we actually have a valid texture name. Now, what is a valid texture name? That is when the texture name value is not null or white space. So if not string that is null or white space underscore texture name. So if we have some string in our texture and it's not a white space, we can load it. We can try to load it. Texture is equal to content.load. It's going to be a texture 2D and underscore texture name. And we didn't get the textures done. So let's go back up to the properties here. Public rectangle get and set. It's going to be private set. Public texture 2D texture get and private set. The origin, which is a vector 2, that's going to be protected. Origin get and private set. And that is it for the properties. So sorry about that, I forgot to add those. Okay, so texture content.load texture 2D underscore texture name. Now we need to set the origin, and I'm going to default that to the center point of the texture. Origin is equal to new vector 2 texture.width divided by 2.0f. That divides the width by 2, and texture.height divided by 2.0f, and that divides the height by 2 as well. And then once we load our texture, we can call rectangle. We can actually create a new rectangle. We provide our int for position.x. It needs to be an integer, so we cast that from a float to an integer. Int position.y, and our texture.width and our texture.height. All right. Now we are done. We have loaded our content. Now we need to provide we need to invoke this event handler here. So I'm going to use the new C# feature null propagation. Content loaded ? Dot invoke this object and event args.empty. I'm not going to provide any arguments. So this is null propagation, and what this does, if content loaded is null, this won't execute. If it is not null, this will execute. So this is a quick way to do, instead of having if content loaded does not equal to null, content loaded.invoke, we just do this in one line here. Okay. There's a few things that it will create. They will probably be out around the same time, if not before this. So my discussing this will be irrelevant, but I will be releasing some C# videos to discuss contravariance, what we discussed in the last video with the I collidable, what this in does, and null propagation. So I'll discuss that in more in-depth. All right, we have a load content. Now let's have an unload content. So that's going to be a public virtual void. Unload content. We're going to dispose our texture. And we're going to set our origin is equal to vector2.0. Okay, so now we need to override our draw entity. So our draw entity is coming from our game entity abstract class here. And we're going to override it. It's a physical entity. It does have a actual physical view for the player. It's a physical entity. It exists in our game. So we need to see it. But we need to see it if texture does not equal to null. If we don't have a valid texture, we cannot display it. And sprite batch is provided to us in the call. That is guaranteed to already have begun, so we don't have to call sprite batch.begin. Sprite batch.draw. We're going to draw the texture here at position, null, origin, rotation, scale vector, color.white. I actually just provide the color here that we specify. So color here, sprite effects.none, and 0f, which these two are irrelevant. That's why ReSharper has those as a lower opacity, so it's difficult to see. So you can completely omit those if you want to. Okay, so that is the draw entity. So that is it for this class. We set up a private read-only string that holds our texture name. That gets us ready to load our content whenever this is called. Load content uses that private texture name in order to load our texture. Then we have our constructor that sets everything up. We have our properties from our interface: color, float, rotation, float scale, vector2, scale vector, and vector2 position. We had to create more properties because our object is physical, so we needed these three properties as well. Told the rectangle, the texture, and the origin. We created an event handler. That way we can have things be notified whenever our content has been loaded, and we can perform more logic. We loaded our content, so if we need to manipulate that texture or we need to do something with our rectangle, we can do that after we have been sure that our content has been loaded. So we can get that set up and we will be invoked and we'll be notified, hey, content is loaded. You can do whatever you need to do with this texture, origin, or rectangle. Unload content just disposes our texture, and our draw entity just calls our basic sprite batch.draw call that we've done multiple times before. There is one more function, one more method I want to add to the physical entity, and that's to update the rectangle. So let's scroll down to the bottom of the class and let's add a new protected void update rectangle. Var top left is equal to position minus origin, and rectangle is equal to new rectangle int top left dot x. We're just casting these as int top left dot y because that gives us our position values. Texture, remember that can be null, so we'll just do question mark dot width. So that turns, if that doesn't exist, that's nullable int. So if that is, our width will just be 0. Texture question mark dot height. If that's null, we'll just set that to 0. Okay, so what is this top left? The origin, we usually set that up to be the center of our sprite. So position 3, 4, if your origin is on the center of the sprite, that's very different than if your position is 3, 4 and your origin is at the top left. Our rectangle goes from the top left of the sprite to the bottom right. It does not use our origin. So we need to take our position value, subtract our origin, that gives us our top left location of our sprite, and then the width and the height will give us our bottom right. Okay, so that's just a quick update. I decided to add this to the physical entity after I did this video. You know, after you finish a project and then you look back and you can find you can make stuff a little bit better. So I added that to the physical entity because any class we can add that will derive from this, that will perform the very same logic. So in order to prevent repetition, I'll just add that to the update rectangle. I'll add that method to the physical entity class. Okay, so that's it for this video. I hope you enjoyed it. Stay tuned for the next video.